in this example, you can see that it has parts A and B. In almost any question that's set up like that, they're connected. A and B will be connected in some way. Almost always, what you found in A, you use in B. And if it's A, B, and C, it could be you may not use what you found in A until later in C. And in C, you might be using what you found in both A and B. But yes, questions with parts are connected in some way. So part A says find the derivative of f of x squared plus x plus 1. So we're looking for an expression for the gradient of a function x squared plus x plus 1. Now, we actually know what that looks like. X squared plus x plus 1, if we were to graph it, would actually be a nice little parabola. And again, I encourage you to do this. If you haven't got GeoGebra on your laptop, download it. And all I've done is I wrote down here in the input space y equals x squared plus x plus 1, and it drew the graph. Now, remember me saying the other day, there is a really nice connection between the algebra that you do and the graphical representation of the function. And it's good to keep making those connections between the two. In terms of the derivative, there are no complications here. Each term has x to a power. There are no square roots. There's no x in the denominator. It's going to be a straightforward differentiation. The notation I would use is f dash x. Well, I don't really want to be in red. So it's f dash of x, bring the 2 to the front, subtract 1 from the index, plus, there's a 1 in front of that x there. Okay, so an expression for the gradient would be 2x plus 1. It says evaluate f dash at x is 0. So evaluate, find the value of f dash, the gradient. Find the value of the gradient when x is 0. Now, I strongly encourage you to say those sorts of things to yourself. Give some real meaning to the notation that you're reading, to the mathematics that you're reading. The real interpretation is find the value of the gradient f dash when x is 0, to show that the tangent at the point 0, 1 has gradient 1. So if the tangent has gradient 1, I think our value here we should get will be 1. Okay, so we've got f dash of x is 2x plus 1. So f dash of 0 will be 2 times 0 plus 1. So f dash of 0 is 1. I guess the only other thing we should do is establish where that 1 came from. We've got this one, and I'd say therefore m equals 1. So we've got the gradient is 1, but to find the rest of this point, I'd say when x is 0, because that's where I am, at x is 0, and it was f dash 0, what's the value of y? Well, we go back to our original function, which is x squared plus x plus 1. So y is equal to 1. So we've got gradient 1 at passing through the point 0, 1. You might be able to conclude for yourself that a possible part C to this could be find the equation of the tangent when x is 0. And if we were finding the equation of the tangent, so tangent is a straight line, we know the gradient, we know the point, we would use point gradient form for a straight line. Or the question could say, find the equation of the normal. Now the normal would go through this point, but its gradient would be minus the reciprocal of 1, which is just minus 1. In example 3, again, it has parts A, B, and C, so they will all be related in some way. So A says find the derivative of this function, and again, there's nothing nasty there. There's no x's in the denominator. There's no square root of x. So finding the derivative will be straightforward. Part 2 says evaluate f dash of 2. Now let's see if we can read that and put some mathematical interpretation on it. Find the value of the gradient when x is equal to 2 to show that the tangent at the point 2, 11 has gradient 3. So evaluating this means we should get the value 3. And again, why the 2, 11? Well, the 2 because we always establish the x location. And where did the 11 come from? The 11 comes from subbing 2 into this. So 9 minus 2 is 7 plus 4, 2 squared, 7 plus 4 is 11. And, no surprise, find the equation of this tangent. Well, we've got its gradient, we've got a point. We'll use the point gradient form. So as you can see now, I've written up the solution. To move through this a little more quickly, the derivative is just using the rule minus 1, 2 times x. Evaluate, find the value, show that the tangent is, show that the gradient of the tangent is 3. And again, we're going to sub 2 into this expression, which is minus 1, 2 times 2, which is minus 1 plus 4, which is 3. Find the equation of the tangent, and we're using y minus y1 is m times x minus x1, and expanding the bracket and bringing the terms together and putting it equal to 0. Just before I move on to 4, oh no, I've changed the equation. Hang on. So if we were to look at our graph of 9 minus x plus x squared, then at the point 2, 11, about here, then we could see, yes, it would have a positive gradient. And do we have to show anything else? No, and we'd just be getting the equation. We've got the equation. Okay, let's have a look at the next example. Find the derivative of 3 minus 2x squared. 3 minus 2x squared is actually a nice little parabola upside down. Just let me see if I can get that up. Yeah, there it is. GeoGebra tends to rearrange the order of the terms, and it's not a problem. It's exactly the same function. And you were probably aware that it was an upside down parabola, had been pushed up to 3. Now, the question is actually asking, so it says differentiate it, so it's in a nice format, there's nothing problematic. Bring the 2 to the front, minus 4, subtract 1, minus 4x. So the gradient is minus 4 times x, depending on where you are. B says solve f dash x equals 0. Solve. Think about the wording of the instruction. If we're solving anything, we're finding values of x. So we're not finding the gradient? No, we're not finding the gradient. We're finding the value of x when the gradient is equal to naught. What does it mean if the gradient's equal to naught? I think it was just back here. Doesn't matter. If the gradient's equal to naught, you will remember me drawing examples of that on the board. The tangent has to be horizontal. If the tangent is horizontal, what does it tell us about the gradient of the tangent? I guess it's saying that. What does f dash x equal naught tell us about the gradient of the tangent? It tells us the gradient of the tangent has to be 0. Okay, so we're solving this minus 4x is equal to naught. We've got our expression for f dash x. Always just think solve means you're finding the value of x. You're finding the value of x. So you need an expression with x in it to be able to solve, and you'll put that expression equal to naught. So if minus 4x is naught, then x has to be naught. So if f dash x is 0, the gradient of the tangent is 0. This means the tangent is horizontal. It may be a maximum or a minimum. Now, we said we had that the gradient of the tangent was naught, hence we've got a maximum or a minimum at x is naught. Our tangent is horizontal when x is naught. Just have another look. Yes, all of that's true. When x is naught, if I was to draw a tangent, it would sit here and it's clearly horizontal. Okay. I think I'll pause the video and do question 5 just so that I can get it through it a bit more quickly. Question 5 says differentiate this function, and it's in a nice format in that everything, no x is in the denominator, no square root, and we're able to see the power and bring it to the front and the constant. And the other reason this is a nice question is because we can understand that graph. X squared minus 2x plus 7 is a parabola. I'll just quickly show you. It's this parabola. I've put it into GeoGebra, and it's a parabola sitting up there, up the right way. Yes, it's a parabola. The question says differentiate that and find the point, and I've highlighted that, and I encourage you to pay particular attention to any question that says point, because a point means you need the x value and the y value. You need to give an answer looking like this, inside brackets with a number here, a comma, and a second number. So you're to find the point where the tangent is horizontal. If you don't have an understanding about what it means for the tangent to be horizontal, you won't be able to get, well, you might be able to differentiate, but you won't know what to do with your derivative. You have to have this added understanding of what the algebra is representing. So we know the algebra represents the tangent, an expression for the tangent. And so it's saying, we want when the tangent is horizontal. If the tangent is horizontal, the first derivative is naught. That's a property about tangents. So put your derivative equal to naught and solve it for x. Now we've got our x value and we need to find the y value. Sub back into your original function and find that y is equal to 6. Therefore, 1, 6, x was 1, y was 6, is where the tangent is horizontal. Let's just check that. Definitely, x is 1, y is 6. If I drew the tangent, it would be horizontal.